In our last session, we tracked the path of matter to see how it moves and transforms. Today, we introduce the second character hiding in every one of those examples: energy. No transformation happens for free. For rice to cook, it needs a flame. For clothes to dry, they need the afternoon sun. Even this block of ice pulls heat from the air to change its state. If you remove the energy source, the transformation stops. All of these processes charge an energy fee. But other reactions do exactly the opposite. A burning log or a gas burner releases a steady payout of heat and light into the room as the materials transform. They pay energy back into the world. Identifying whether a process charges a fee or pays a dividend is the first step in understanding how nature manages its accounts. This energy exchange is often completely invisible to us. A standard remote control battery acts as a quiet energy payer, providing power without the need for a flame. Inside the battery, materials are undergoing a slow, steady transformation. The energy paid out by this reaction leaves through the metal contacts as electricity, continuing until the internal materials have completely changed. Your own body follows this same logic. You receive a deposit of energy from the food you eat and pay it out to move your muscles, fuel your thoughts, and maintain a constant body temperature. Whether it is a human muscle or a lithium battery, energy is constantly in motion, transferring from a stored state into an active one. Since wood pays out so much energy when it burns, we have to ask where that energy was located before the fire started. Materials like wood, coal, and the food on your plate function as energy pantries. They hold energy in a stable, quiet state until a specific transformation, such as combustion or digestion, releases it. This stored energy begins with the sun. For years, a tree captures solar radiation and uses that energy to build its physical structure, essentially packaging sunlight into the fibers of the wood. A burning log releases years of accumulated solar energy back into the environment in a single burst of heat and light. Tracking any energy source backward almost always leads to the sun. The power we use every day is largely recycled solar energy. Fossil fuels like coal, oil, and gas are also solar pantries, though they operate on a much longer timeline. These fuels are the remains of ancient plants and microscopic organisms that were buried and compressed under layers of rock for millions of years. Nature took millions of years to fill these underground pantries, but we are emptying them in just a few generations. Burning these fuels releases carbon dioxide, a gas that traps solar heat near the surface. While this effect always kept our planet habitable, rapid consumption has increased this gas, causing the atmosphere to retain more heat than before. The rising temperature of the planet is the direct result of our energy math. We are flooding the atmosphere with millions of years of stored carbon and solar energy in a geological heartbeat. Map this energy journey to your plate. The sun fuels corn. A chicken eats it, storing that energy. You eat the meal. The energy moving your hand right now is relocated sunlight completing its trip from star to muscle. This logic extends to the entire world. Solar heat drives the water cycle for hydroelectric dams and creates the temperature differences that move the air, generating the wind power you see here. In this system, energy is never created from nothing. It is only transferred between places or transformed between states. Looking at the world like a chemist means asking two permanent questions about any transformation. First, where did the matter go? And second, where did the energy come from? Matter never disappears. It only relocates. Energy is never created. It only flows. When you start asking those two questions automatically, you are already thinking like a chemist. In our next lesson, we will use these tools to finally define what chemistry actually is. See you then.